Okay, this is a third of the 4 problems that I gave you to work through. We are going to be looking at finding the area of the region. Wording's a little bit different here. Notice that I said enclosed by 2 curves versus in the last 2, I gave you 2 different x values, and it was sort of random on my part in terms of from here to here, and those became the limits of integration. So that's the one thing that you're going to need to keep in mind as you watch this video, the one slight difference. If you want to give it a try, go for it. Correct answer is 9/2 or 4.5. So not to spoil it, but I wanted you to know if you didn't get that, follow along and see where you went wrong. If you haven't tried it yet, pause the video, give it a go, and pick up where you need to. So I told you in the other ones, I do like to sort of give myself a sketch, although I know this is using some just basic graphical sense here, a negative parabola. So flipped upside down, shifted up 2 units, and I think that's going to be my top curve. So I've got up 2 units, puts it here, and then basic graphing of parabola. I'm not going to be super detailed here. Just give myself... something like that, and then I've got y equals -x. That one's an easy one. Down 1 over 1, down 1 over 1. Okay, so my goal is to find the area between those, and that is certainly this region right here. So good news, if you're doing these in order, this is not like the second one where I have to change my top and my bottom curve. So I'm only going to need one integral. The problem is that I need to know what these locations are for my limits of integration. And because this one, if you graphed it detailed enough, we should be getting -1, 1 as a point of intersection, and 2, -2 as a second point of intersection. I'm concerned specifically with the x values there. If you're not able to get that from the graph, you're forgetting that, or sometimes we don't get nice whole numbers. There's going to be a sort of a necessary first step to these that the other problems did not have, and that's going to be find the points of intersection. So just a quick reminder on that. We'll see it works out for this one, and then we'll need to use this in a future problem. That will be setting the 2 equations equal to each other. So basically solving a system of equations. They're both solved for y. So I can take my 2 minus x squared, set that equal to -x, and we're going to find any points in common. We know there's 2 of them, and let's do a quick check here. So I've got a quadratic. That's going to put me into this quadratic equation, and I think this is factorable. Should be, since I got nice numbers there. X minus 2, x plus 1. So those are getting me the same x values that I had, but like I said, good strategy to know if we get stuck. I'm ready to do my area, so I'm going to go from -1 to 2. Those are the limits that I just came up with. And like I said, top curve is my parabola, 2 minus x squared. Bottom curve is the -x. And I'm subtracting, it's f of x, top curve, minus g of x, my bottom curve. So I actually have a minus a negative, which is going to end up being plus a positive. So, antiderivative. See why we practiced all those? 2x minus x cubed over 3 plus x squared over 2. Evaluating from -1 to 2. And if you were getting lazy when we had a 0, a lot of times things canceled out. Nothing's going to cancel out here. So I'm going to get something minus something, plugging in the 2 and plugging in the -1. And I've got a -1/3 plus, minus a -1/3, so that's going to be plus 1/3, and then plus 1/2, if I'm doing my math correct. I'm going to go ahead and distribute and combine what I can. That I could have put together, so let's go ahead and put that together as 6. So I have a 6 minus 8/3. Distributing, I get a minus a negative 2, which is plus 2, minus 1/3, and minus 1/2. So I've got 6 plus 2, 8 is my whole number, negative 1/3, and negative 1/3 is negative 9/3, which is a negative 3. Minus 1/2, I'm getting to 5 minus 1/2, and there's your 4 1/2, or 9/2. So, final answer. Like I said, really great work with just practicing our integration. Obviously, you could also just plug in the calculator if you're looking to check these on your own. Hopefully that helps. Give the last one a go, and you are done.